Okay, so now we've been looking at these numbers, and let's see what we can circle here. So what's the first number that I circled?
9.7.
This is 9.7. So I have 98, 98, 98, 98, 9.7. So this one is less. And what's the next one?
9.9.
10.0 and December.
No, why do you say 9.9?
Do you read the annual?
So there's a 10.0 here, right? Do I read the annual average stuff here? No, I don't care about any of these stuff. So I just care about the 12, the data for each month. So 10.0. What's the next one?
9.9.
And there's a 9.9 here, right? And then there's a 9.8 here. And there's a 10.1 here. Another 10.1. Okay. There's a 10.0. A 9.9. Now, can it ever happen that one of them gets circled in the first column?
No, because there's nothing's going to be less than before.
May I direct your attention to January of 1921? In January of 1921, it was less than as December of 1920.
So it counts what was in the previous line?
Yeah. I mean, the calendar year is just an artificial thing, right? I mean, if the inflation rate was less in January than in the preceding December, it was less.
Okay.
Right?
I know. I just didn't know if like the program itself
Okay.
separated lines and like only
All
counted.
right. So here, the reason I'm doing this exercise here is because there's a common misconception in the mind of the student who conflate the task to be solved and the program that solves it. So the first thing, before writing any such program, is to figure out what is the task to be solved. We have to understand the task to be solved in its entirety before it makes sense to write a line of code. And this is a hard thing to do for people. So I've gotten a couple of questions already that said, should I use a while loop or a for loop for this? And that's like saying, okay, I'm going to plan my plan of study. I'm going to study computer science, and then I'm going to apply for a job. Or should I use the train or the car this morning to go to work or to go to school? I mean, there's a big difference between the long term and the short term here. So right now we're trying to understand what is it that we're supposed to do. And it's very important that one does that, because if you can't do it by hand, you can't code it. This is the single most important fact that you're going to be learning in this class. So I'll repeat it. If you can't do it by hand, you can't code it. So the next time that you ask yourself, why am I stuck? Why can't I make any progress? Ask yourself the question, would I know how to do it by hand? And if the answer is no, move away from the computer. Move far, far away from the computer. Get yourself on a separate desk where you have paper. A printout like this where you have a big data set. The printout is great. And then just circling the numbers with a pencil is a great way of familiarizing yourself with the problem. So pay for that printout. It is definitely worth it. And it's something that is so hard for students to do. I know it because I see it all the time. Students, they're glued to the computer. We're going to look at this data. We're going to look at it. We're not going to move away from the computer until it's all done. But it's the wrong way of approaching this. You have to understand the problem first. So in this situation here, in January 1921, inflation was less than in December 1920. And yes, since the answer is we want to find out whenever did it actually go down, we need to print that. Okay. So, and we're not asking an unreasonable question here, right? Generally, when you think of inflation, you think of the consumer price index goes up, 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 up. But once in a while, you have these deflationary periods that are actually somewhat potentially dangerous. In the late 70s, there was a period of deflation that actually hurt the economy quite a bit, and who knows what went on in the 20s. We'll find out. So I would kind of like to know, how many times did this happen? Did these events come in clusters? And for that, it's an interesting data set that one wants to look at. All right. Now, the other reason why it's dangerous to think about the program too early is that intuitively there was a reason why he recoiled when he thought about this situation. Why he said, "Do I really have to do it?" And that is, it might be harder to program, right? It's already thinking in terms of loops and stuff, and so people will then intuitively try to avoid the things that they think are hard to program. Now, as it turns out, in this case, it's not hard to program, and so there was no particular reason to be nervous. But people are often, very often, when they first look at the problem, they already have these preconceived notions, what might be easy, what might be hard to implement, and then they start implementing a partial solution, which is just setting yourself up for less than complete success. So it's really important to first look at the problem. So what we need to figure out is, how can we get this stream of data and figure out when something goes down. So how do you do this? So if you just do it by hand, you kind of have to, how do you know that this one here was worth circling? You had to look at the previous one, right? That's all there is to it. So if you could get yourself a steady stream of data, if each time you had the previous one available, then you can do this. Well, then you can do the circling part. Now let's go to part 2 of this thing. We need to figure out, what are we supposed to print out? So let's do that here. What are we supposed to print out? First month or first year?
Month.
Okay, so what's the first thing I print out?
Month. Like, isn't that, it was month?
Okay, the month and the numbers or in letters?
Letters. I think, right? Because it's the string, like January, February.
Well, what did so he says letters, he says letters.
Example was 5.
Yeah. Excellent. Okay, so you remember the example, and so there it did say, right? Oh, now I lost my number. This thing really. All right. So it was 5, 19, 13. And then I printed 9.7. So that means that I already realized that I have to have the current value available. I have to have the previous value available. It catches up with me. I have to have the month. And I have to have the year. Right? And so if I have these 4 values available at all times, then life is good. Because then I can say, if the current one is less than the previous, print out the month, the year, and the current. How do I update them?
Well, you could. I'm like, yeah.
Yeah, so the current one into previous, did we see this? We had some program where we had a similar situation, where we said previous equals current. Right, and then I do a month plus plus. And how do I get the new current one?
And yeah, you
Yeah.
mean just to get the current month, you could just say like what, or just get next or whatever previous
it's
double.
in dot next double. I just read in the next number from the scanner. And that kind of gets me far. Now there's going to be some nasty cases. What happens at the end of the year?
It gets to 12, and then you have to go back to.
Well, you're not going to see the 12. what are you going to see? You're going to, so this is the other important observation. Let's make sure this sinks in for everyone. The other important observation is that how are you going to be seeing these numbers? You're going to be reading in 12 numbers in a loop. And then what happens? And then you want to exit that loop, throw away the rest. How do you throw away the rest? How do you throw it away?
If you're in an if loop, make it like if.
How do you throw it away? Yes? You call in dot next line. Next, it's important to use next line, because if you call next, it'll read the next thing. And there was some variation in how many numbers there were at the end. There weren't quite as many in the first few than in the others, I think. We can't see it on here because it would scroll. Or in the last ones. Yeah, the very first one didn't have quite as many. But if you call it next line, it just junks away whatever was there at the end of the line, and you're good. So you read 12 numbers, and you call next line. And now then you have to have a bigger loop, because you're going to have to do this. Read 12 numbers, throw away the rest. Read 12 numbers, throw away the rest. Read 12 numbers, throw away the rest. You have to do that lots of times. So you have a loop inside a loop. So that's the basic thing. Now someone asked, what was I supposed to do for the draft? And so the general idea is when you make a draft is that you should use your best judgment as to how far can you push this thing along. And I put something on Desire to Learn what I would have done for this draft. So I would have taken the first couple of lines of instructions. It said, keep reading this stuff away until you find a line that starts with year. That sounds like an easy enough thing to do. So that would have been something that would be worthwhile putting into the draft. And then I do realize that all the hard part is left. Well, this is a hard problem that's probably going to take me several days to solve. So you might say, what is the value of having a draft that doesn't really do anything? But you'll be surprised. Having that program up to that point, so that next time that you have the drive to continue it, that you already have it all set up, and you don't have to worry about public static void main. And you already have fed in the text file, and it's at the right place. And that means that next time that you have the extra energy to push it forward, it's all already set up. And it does make a difference. I ran into this thing this morning. I had to do some hard problem for something else that I'm doing. And I kind of dreaded getting started, but I made myself getting started before taking a shower. You don't want to know all those details, I suppose. But then when I was in the train, it was all set up. I was ready to go. I had some creative energy, and I did not have to dissipate my creative energy with writing public static void main. I was able to hit the ground running. So it is important to have these things. And of course, the other reason is that it makes you read through the darn problem, and so that way you can ask questions. More questions about this problem? Okay, so I don't want to beat this to death, but it's important that you realize that you first get out a sheet of paper, do it by hand, and once you actually know what it is that you're doing, then you can go and start coding it. So it's not actually a hard problem. It's a problem that's not a routine problem. It's not something you could read the entire chapter in the book, and there wouldn't be a single sentence that says, this is how you get started with this particular problem. The book talks about loops, and while loops, and for loops, and nested loops. And, I tell you, you need a nested loop here, but that doesn't really do you any good, because the example in the book for nested loops is something entirely different. The concept of nested loops is not rocket science. You have a loop inside a loop. Hardly worth having a whole section for it. But to actually adjust the nested loops, of course, to get them to work right, is not trivial. All right. So there's a few things in this chapter that I do want to go over. First one has to do with for loops. We don't find this here. So if you look at this little table with examples here, and I want to get into this issue, how often does a for loop gets executed? So over here, I have a loop that says I equals 0, I less equal 5, I plus plus. How many times? How many times does the loop get executed? 6 times. But it says I less equal 5. Yeah, it is 0, 1, 2, 3, 4, 5, and if you count them, that is in fact 6 values. And this is often confusing for people that when they see it the first time, that because we have a less equal here, and we start at 0, that means we actually have 6 values, and the 5 is a little bit misleading. What if I wanted to have it run only 5 times?
Just make it less than.
I could do a less than 5, or I could start from 1. Either of them would be good. And it depends on what I want to do. Now it's very, very common that in Java that you want to start from 0 and go 1 less than a number, and that's the example here. When you traverse the characters in a string, you want to start at 0 because the first valid index is a string, in a string is 0. And you want to go 1 less than the length of the string, because suppose you have the string hello, you want to go 0, 1, 2, 3, 4, and whereas the length of the string is 5. So the equal 0 less than something is a very, very common loop. And you just want to pay attention to that. In general, you just need to remember that when there's a less than equal here, that means you have 1 more than you're probably thinking about if you start with 0. Of course, if you start with 1, everything works out fine. So I goes from 1, I less equal 10. How often? How many times? 10? Or 11? Or 9?
4.
10 times, right? Because it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Which we all know is 10 times. So this one worked out because there was an equal 1. We started at 1 and we go LX equal 10. There's a general formula in the book that you can look at, but you'll probably find it unintuitive. So look for, does it go from 0, does it start at 0, 1? Does it go less than equal or less than? And then figure it out from there. So I must have designed a number of quiz questions like this, because this is just a common thing for people to mention. Once in a while you have a for loop that goes backwards, and then you have an I minus minus here. And that would happen if you go like backwards. Why would you ever want to go backwards? Why would you want to see some high number and then go all the way down to 0? Yeah, what if you want to reverse something, right? So let's look at the reversing a string thing. There you might want to see the last character in the string, and then the penultimate, and then the anti-penultimate, and so on. So in that case here, how would we do that? So here I have my string. So where should I start? Well, I want to go backwards. I want to go 4, 3, 2, 1, 0. Yeah, length minus 1. Excellent. So string. Where do I stop? At 0, exactly. Like that? Ah, I minus minus. And actually, that's a mistake that I often do when I go backwards, because my fingers know the plus plus so well that I type the plus plus without thinking. What would happen if you had the I plus plus? Yes, it would. It would probably get an infinite loop, and it probably would be an out of bounds, because I would go from 4 to 5 to 6 to 7 to 8 and so on. Okay, there's another mistake in here. It has to be greater than equal. Again, when you go backwards, you have to flip this thing. What would happen if I put in the less than equal 0? That would never be true. So then what would happen? What happens with a for loop where this condition is never true?
It just.
Will it cry? Will it shed tears?
Yeah. It'll give up.
It'll just give up.
Yeah.
Yes. It'll check the condition. It'll say the condition is not true, and it'll not even enter the loop. It'll just not do anything. All right. So here's the correct loop. I start at the length -1 because we don't want to have to find. We go greater or equal 0, I minus minus. So then, of course, I could say let car c equals string dot car at I, and this now delivers me the characters in reverse order. O, L, L, E, H. What you do with these characters in reverse order, that's now up to you. Just act responsibly. All right. So that was one thing that I wanted to talk about, the for loop. Sometimes people ask, when should I use a while loop, when should I use a for loop, and when should I use a do loop? And the practical rules are actually very simple. You use a for loop when you have something that goes from 1 to n, from 1 to 10, or the other direction, from 10 to 1, in regular increments. If you know already how many times the loop gets executed. So for example, you would use a for loop if you know that you need to read in 12 numbers, if there are always 12 numbers. So in the homework, in that hard homework, do we use a for loop for reading in one row? Yes, he says. The man with conviction, because there's always 12 numbers. Except, where aren't there 12 numbers? At the very last row, and we don't know as we read them. We don't know when that last row is going to come. So I wouldn't use a for loop here. I would say because the last row doesn't use 12 numbers, I would use a while loop. So only when you know that the problem is completely homogeneous, you would use a for loop. In this case, I would use a while loop even for the inner loop. For the outer loop, I would also use a while loop because you have no way of knowing how many numbers there are. Which reminds me, you should not rely on that you're going to get this exact same data set, of course. You might get a data set that's subtly different, that has a few more years, a few fewer years. You can rely on the fact that the years will come from Earth where there's 12 months to the year. I'm not going to give you the ones from Mars where there's 7 months to the year. Trivia fact of the day. So you get 12 months to the year, but you don't know how many years. So you would use a for loop only if you have a very uniform situation, and that often means strings where you have the length in advance, and your months where if you really know that you always have full months. When do you need to use a do loop? So I'll tell you a little known secret. You don't ever have to use a do loop. You don't like do loops? You can forget about do loops because you could always set a Boolean variable. The vast majority of loops that occur in practice are kind of irregular anyway. They have to form. You need to do a little bit of work. You then figure out whether you need to exit, and then maybe you need to do more work. And so a do loop is just a special case of that. And so you don't really need to have a do loop. Why do I cover do loops in the book? Because when I omit them, there's hundreds of professors who adopt the book who say, you're not covering do loops. It's an essential feature. Every student needs to know it. So that's actually not true. You can lead a happy life without ever writing a do loop. I think of all of the loops that I've ever written, less than 5% are do loops. And probably most of them are because I needed to come up with an example for a textbook. So forget about do loops. They're not there. I will make sure they don't get tested on the exam either. Once in a while they're handy, but it's not like solving world hunger. All right, that's kind of what I wanted to say about what's in the book here. In the other thing I want to cover briefly is how to run the debugger. So let's see the best way to do this. So let me do this with the solution for 16C. Was this homework 16C? Was it 16C or was 16D, right? There was this perennial problem with that. Find this. All right, so let's run this guy. Pick input text. Oops, and I'm getting a Java util mismatch exception right away. So, did I give you the wrong answer?
Yeah.
All right.
Certainly.
No, I'll show you in a minute what happened. So now I might say, what the heck? Why did I get this? And so my program has died. I can see the place where it died because that's where BlueJ stops me, and I get this report here. And now I might want to figure out what happened. So what did you guys do so far to? You must have had this happen to you at least once. No? Everyone managed to get this thing working correctly on the first try? Yeah, you had a different error. Of course, you didn't have the exact same error.
Yeah, different error.
All happy programs are alike, but all unhappy ones are unhappy in their own way. So, so you must have had some kind of error, and then what do? Now, of course, the correct thing to do is to look at the input and to carefully trace through the program, one statement at a time, and then figure out exactly where your program went wrong. And for a short program, that's actually pretty effective. You can, look at the input file. See where I have it. It's here. And you can then look at all of the calls that you have in your program to, now where you call next line, and then I can say, what did next line do? Or it consumed this entire line. Print the thing out, cross out the thing. Then we go and call next int. What did that do? Well, that would have read in, that was taken away this integer, and so on. So you can cross it out, and you can follow through and see that the right thing happened. But sometimes, as your programs get more and more complex, that's really tedious to do, and at that point you want to learn how to use this marvelous tool called the debugger. So the debugger will run your program kind of in slow motion. You can get up to a particular point, and then you can see what's happening. So let me show you how to do this. What I have to do is I have to set a breakpoint. So I'll set one here. And you set a breakpoint in BlueJ very simply by clicking on that leftmost strip, and then you get a little stop sign here. So now let's let's run it again with that.
What does the breakpoint do?
So the breakpoint will make the debugger stop as soon as you reach this line.
Oh, okay.
And we'll see it in a minute in action, and you'll see what I mean. So now I'm going to run the program again. Text. And now here, over here you can see that the program has stopped. You see the yellow bar, but it's not dead yet. It's not like with the exception throw when the program was just dead there, bleeding on the floor. In this case, the program is still very much alive. It has just been suspended so that I can look at what's happening. So over here, I can see the local variables. So I can see that done is currently false. So let's see, can I see what's the description? Because I would like to see, did it read in the first line of input? But I can't quite yet, because when it's on the yellow line, that means it has not yet executed it. So now I can execute this line just by itself by clicking on step. And when I click on step, you see that the yellow bar moves to the next line. And you can see over here that the description has been filled with consumer price index. So that's good information that now you know it has correctly read in the first line. So now let's click step again and see what happens next. So here it says does description equal end, which was not the case, and therefore the step goes, it skips past the if, it goes into the else. So now we know that's gone to this part, and that's also what we actually expected to happen. If we look at the input here, we expected it to consume the first line here, and it doesn't say end, so we expect it to go on and now read this integer. Let's see if it does that. So where's my debugger window here? So I click step again, and now if we look carefully over here, we can see that it did read the input. This window here now is getting bigger as we get more local variables, and you can see it read 1997 over here. So the program is truly executing in slow motion. You can see it one statement at a time. So this is incredibly useful to see where things go wrong. So now I'm going to read amount. So let's step over that. So I click step. Ooh. And now my program has died. So yeah, the poor little thing. So here is the error message. And we can see from the error message exactly where it's died. It's died in line number 25. How do I see that this is line number 25? There's another useful thing. You can show line numbers somewhere. Options, preferences, display line numbers. You actually want this on. So where's line number 25? So it died in this line. Okay, now let's look at the output. So here it was reading in 160.5 and it failed. What could possibly be wrong with 160.5?
Nothing. Program's wrong.
There's nothing in front that could be wrong. It's called read double.
Well, it's
All right, I don't
it's
think
the
you.
correct answer. I
Yeah.
mean, one.
So I don't think that you would know. What happened is that my computer is right now running in, and you might have noticed that some of the messages, like in the browser, you notice that they're in French. So it's running in French locale. In French, how do you write 160.5?
Just comments.
Exactly, very good. You write 160,5. In most languages, other than English, people use the comma as the decimal separator. And so what I'm going to have to do is I'm going to have to replace the dots with commas, which is not what happened. Dots with commas. And then we'll run it again. There's my here. Okay, now I'm at my breakpoint again, here. And now I just say I just want to continue because I'm confident that everything will work fine. And so it printed this, and I'm at my breakpoint again because the breakpoint is inside a loop. So I can continue, get another line output. And now at this point I can be so confident I might want to erase this breakpoint just by clicking on it again. And now when I say continue, the program will run until the end, and everything is fine. So particularly if something bizarre happened, the debugger is great because it shows you in no uncertain terms how far did your program run, when did it stop, all of that good stuff. And so I can't overemphasize how useful this information is. Now, so everyone should learn the debugger, and like everything else, when you first learn it, it's a pain for the first hour or so, and it takes a little bit of energy to get yourself up to using the debugger. What students mostly do, and even what professional programmers mostly do, is they kind of dread getting up the debugger and getting into debug mode. They put in print statements instead. Has any of you done that in development? See, I mean, it's a common thing that people do, right? You put in a print statement that says, "Yoo-hoo, I'm here," and then as your program progresses, it prints these print statements, and it's a good technique. It's nothing bad about it. It's just as your programs get more complex, you end up having lots and lots of printout to read through, and it's just time-consuming. And also, then when your program finally works, what do you have to do?
Delete all the print statements.
You have to delete all the print statements, and then what happens?
You might have made a mistake.
Then you find that you made a different mistake, and you have to put them all back in. And that's what people get fed up after a while, and that's when they realize that using the debugger is actually a good thing. So the debugger is great because it enables you to run your program at full speed up to a point where bad things might be happening, and then you can do it one step at a time. One minor thing that you're going to be exploring in the lab that I haven't needed to use here. Notice there's two buttons called step and step into. Step into steps inside a method. So if you have a program that calls another method, which homework 16D just didn't have to do, then you could actually step into a method and see it. But sometimes when you know that the method already works, you can just step over it and have it run at full speed. So we're going to be practicing that in the afternoon. All right, so that gets me to the end of the lecture. Didn't mean a lecture this long, but that's the way it goes. I have yet another idiotic meeting that I have to go to, so I'll be back around 12:30. So get going with the lab. You can have lunch now, or you can get going with the lab, whatever you and your partner want to decide. Get going with the debugging lab, it's called. So it's at a different location. You have to go into the Dropbox, and it gives you the URL where it is. The first part of the debugging lab just is not yet related to debugging, just makes you look at a stack trace, and then it goes full on with the debugger. Get going with it, and then when I come back, I'll see where everyone is at. And then if everyone's been working over lunch, then we can finish early. Whatever you guys want to do. Any questions? Everyone knows what to do?